All right, today we're diving into a project that could, and I mean really could, change how we create things. We're talking about building a custom digital synthesizer, but the how is something completely new.
So just start with this question. What if you wanted to build something really complex, with microcontrollers and custom code, but you didn't have to write a single line of it? What if you could just describe it, tell an AI partner what you want, and it handles all the hard stuff? Well, that's the exact experiment we're going to break down.
So what does this actually look like in the real world? Well, the goal was to build a digital synthesizer module, a Eurorack module called Watasoge. But instead of the usual headache of coding and configuring everything by hand, the creator decided to try something totally different.
And this new approach has a pretty cool name, vibe coding. Basically, the human provides the vibe. The big ideas, the creative direction, and the feedback. Hey, that sounds good. Or, no, that's not quite right. In the AI partner, it handles all the nitty-gritty, the low-level code. You're the director, and the AI is your super talented engineer.
And this right here shows you why this is such a game changer. Anyone who's done this knows the old way can be a nightmare. You're wrestling with these fiddly config tools, digging through hidden menus, it's just tedious. But with vibe coding, the whole thing becomes a conversation. You just describe what you want, and the AI takes care of the rest. It really shifts from a technical chore to a creative dialogue.
Okay, so the theory is great, but does this stuff actually work? That brings us to the very first big test. Could this new method even make a piece of hardware do anything? Could it make that first, crucial sound?
The process was just shockingly simple. First, to see if anything was working, the creator told the AI, blink the onboard LED as a sign of life. And boom, the light started blinking. So then came the real test. Okay, now generate a 440 Hz sine wave. Just 5 minutes later, a perfect, clean tone was coming out of the speakers. And get this, the creator never touched a single line of code or a single configuration file.
You can just feel the creator's reaction in this quote. This wasn't just, a little bit easier. It was a total paradigm shift. It was like jumping from being the mechanic with greasy hands to being the conductor of an orchestra. A whole new level.
So look, a single tone is one thing. That's a great proof of concept. But a real musical instrument needs to make all kinds of complex sounds. Getting from that one simple beep to a full-on synthesizer is a huge leap. So let's see how vibe coding handled that.
So the creator asked the AI to generate a whole bunch of wave tables. These are like the tiny sound DNA for the synthesizer. And the first shot, it wasn't perfect. The result was a bunch of clicks and pops, not musical tones. And that's actually a really important part of this story. It's not magic, it's a back and forth.
But this is where the whole vibe coding thing just clicks. The creator didn't have to go debug lines of code. They just had to give simple feedback, describing what they heard. They just said, it's full of clicks and pops. And based on that, the AI went back, figured out the problem, and fixed it. And the final result here is just, wow. After that one little piece of feedback, the AI didn't just fix the problem. It churned out 220 perfect wavetables. A whole library of sounds, melodic and percussive, all ready to go. That's the power of this kind of conversational workflow. And it didn't even stop there. The creator then asked the AI to clean up the code, to make the whole software architecture better. They just described a cleaner structure with different modules for creating the sound, sending it out, and deciding what to play. And the AI just understood. It refactored the entire codebase, all from one simple prompt. Okay, so the wavetable synth is working, it sounds great, the code is clean, but what if you push it even further? The creator decided to add a completely new and much more complex type of sound to the synthesizer. The sounds they had were awesome, but they were missing that classic, plucked string sound. And that's not something you can just fake easily with the method they were using. It requires a totally different approach under the hood.
So let's quickly look at the difference. Wavetable synthesis, which is what they'd already built, is kind of like playing back a tiny recording over and over. But to get a realistic plucked string sound, you need something called carpless strong synthesis. This is totally different. It actually models the physics of a string using a burst of noise and a feedback loop. It's a way more complicated algorithm to get right.
So the creator tells the AI to implement carpless strong. First try, it fails. Total silence. But here is the absolutely mind-blowing part. The creator just reported back, there's no sound. The AI then re-examined its own code, identified its own mistake, and fixed it. It debugged itself. So let's just step back and really think about what this means for the future of making things. This entire process points to a massive shift in what it means to be a creator, a coder, an engineer.
It all boils down to this simple, powerful idea. The human's job shifts. You're no longer the one down in the trenches writing every single line of code. You become the creative director. You're the conductor. You provide the vision, and the AI becomes this expert partner that handles the incredibly complex execution.
This whole project, building a complex piece of hardware just through a conversation, really leaves us with one huge, exciting question. If all those technical barriers, the tedious setup, the deep, specialized knowledge, if all of that starts to fade away, what could we all create if the only real limit left was our own imagination?